Okay, in this video we're going to look at solving rational inequalities, and they're very similar to solving nonlinear inequalities, except now we have a denominator that we have to look at. So our first step is to take a look at our denominator here and see what makes our denominator is 0. So we set our denominator equal to 0 and solve. And we find out that 3 makes our denominator equal to 0. Most of you could have seen that right off the bat. So I'm going to locate 3 on my number line. And we know that if we plug in a 3 back in, we'll get a 0 in our denominator. We're not allowed to have zeros in our denominator. It makes our rational expressions undefined. So 3 cannot be a solution. So I will mark it on my number line with an open dot to signify that it cannot be part of my solution. The second step is to take my rational inequality and change it into an equality and solve the related equation. So in order to solve a rational equation, I find the LCD and I multiply both sides by the LCD to eliminate my denominator. So on the left-hand side, my x minus 3's cancel out, and I'm left with x plus 2. 0 times anything is 0. And when I solve that, I get x equals negative 2. I'm going to locate negative 2 on my number line. I'm going to take a look. I've got less than or equal to here. So when I solve this equation, it makes it's solving for the equal part, and since my inequality sign has an equal sign in it, negative 2 is allowed to be a solution because it makes my rational expression equal to 0. So that is included because I have the equal sign. If that equal sign was not there, I'd put an open dot. So my next step is to work this now in a very similar fashion to solving nonlinear inequalities. Just pick a test point from each of the regions. So in this left region, I'm going to pick a negative 3. And when I plug that into my original inequality, I get negative 3 plus 2 over negative 3 minus 3. I'm going to compare that to 0. So I get a negative 1 over negative 6 is less than or equal to 0. Which is 1/6 is less than or equal to 0. 1/6 is positive, it's not less than 0, so I'm going to put a false in this region. The easiest number in the middle region to pick is 0, so I'm going to try 0 plus 2 over 0 minus 3 is less than or equal to 0. I get 2 over negative 3, which is a negative 2/3, which is definitely less than 0, so I'll put a true there, and I'm going to pick a 4 from my rightmost region. I get 4 plus 2 is less than or equal to 0. 4 plus 2 over 4 minus 3 is less than or equal to 0. I get 6 over 1, which is just 6. 6 is not less than or equal to 0, so I'll put a false here. So it looks like the only region that has a true is this middle region here. Let's go ahead and write it in interval notation. My endpoints are negative 2 and 3. My 3 has an open dot, it's not included, so I use a parenthesis. My negative 2 is included, it has a closed dot. I use a closed parenthesis, or a square bracket, Okay, so if you need to write this example down or need more time to, go ahead and pause the video because I'm going to go ahead and erase. And we're going to do a second example up here. Okay. Okay, for my second example, I am going to work this problem. P over P plus 4 is less than or equal to 3P. Alright, so again, the very first thing I do is I take a look at my denominator and I set it equal to 0 to find out what makes my denominator 0, because I need to disclude that from my solution set. So I'm going to locate negative 4 on my number line and put a nice open circle around it so that I don't include it in my solution set. The next thing is to change my inequality into an equation and solve this related equation. So I find my LCD and I multiply both sides by the LCD, and on the left hand side that cancels out my denominator, so I get P equals, I'm going to go ahead and distribute this across both of my terms here, 3P squared plus 12P. Okay, so how do I solve this equation? I move everything to one side and set my equation equal to 0. And to solve this one, I go ahead and factor. Looks like that's going to be the easiest way to solve this. So when I factor, I'm going to pull out my GCF first, and I'm left with 3P plus 11 inside parentheses. So I get to set each one of these factors equal to 0, and you notice I have two factors. So the first one, when I set it equal to 0, P equals 0. The second one is 3P plus 11 equals 0. And when I solve these, I get P equals 0 and negative 11 thirds. All right, so I need to go ahead and locate these numbers on my number line. Negative 11 thirds is very close to negative 4. So it's a little bit greater than negative 4, so I locate that. And 0 is over here. So I have numbers that divide my number line up into 4 different regions. Because my inequality has an equal sign, these new solutions, I'm putting closed dots on them. So how do I solve something like this? Well, I'm going to do the same thing. I'm going to pick a test point from each of the regions. So I'm going to go ahead and pick negative 5. I'm going to plug that into my original inequality. And I get negative 5 over negative 5 plus 4 is less than or equal to 3 times negative 5. So I get negative 5 over negative 1 is less than or equal to negative 15. Negative 5 over negative 1 is a positive 5. Positive 5 is not less than or equal to 15, so I'm going to write F on top for false. That region is not part of my solution. So now I need to pick a number in between negative 4 and negative 11 thirds. So if I was going to convert negative 4 into a number over 3, I would go ahead and convert it into negative 12 over 3. What number's between negative 12 over 3 and negative 11 over 3? Well, it doesn't look like there is any, but I can rewrite both of those into a fraction over 6. And then I'll have a number that I can plug in. So this one becomes negative 24, and this is negative 22. So I'm going to go ahead and use negative 23 over 6 as my test point in my middle solution. So negative 23 over 6. I need room to actually solve, so I'll erase this. And your homework problems shouldn't be, you might have one that's this complicated, but most of them shouldn't be this complicated. You should have nice whole numbers that you can plug in. So let's go ahead and plug in a negative 23 over 6 into P. Less than or equal to 3 times negative 23 over 6. And I still have, let's see, negative 23 over 6. And when I add these, I get negative 23 over 6 plus 24 over 6. It's less than or equal to, let's multiply that, negative 69 over 6. And let's continue with that over here. Negative 23 over 6 divided by 1/6 is less than or equal to negative 69 over 6. When I divide fractions, I multiply it by the reciprocal. So negative 23 6 times 6, that eliminates my denominator. So I get a negative 23 is less than or equal to, let's reduce this fraction here. They're both divisible by 3, so I get a negative 23 over 2. Okay, so negative 23 is definitely less than negative 23 halves. So this region here, I'm going to mark with a true. So I'm going to erase some of this math so I can plug in more numbers. Oops, I lost my box. I can plug in more numbers and test more areas. Okay. So in this region, I'm going to plug in a -1. So into P, so I get a -1 over -1 plus 4 is less than or equal to 3 times -1. That gives me a -1 over 3 is less than or equal to -3. -1/3 is not less than or equal to -3, so I'll mark that with a false. And then my last region, I will plug in a 1, and I get a 1 over 1 plus 4 is less than or equal to 3 times 1. And that gives me a 1/5 is less than or equal to 3, which is true. So now when I am looking for the regions, I pick my true regions, and I have 2 of them. So I'll write my answer in interval notation. My first leftmost region has the endpoints -4 and -11/3. -4 is not included, so I use a parenthesis. -11/3 is, so I'll use a square bracket. And then my last region goes from 0 to infinity. 0 is included, so I use a square bracket. And that's how you solve rational inequalities that don't necessarily have an inequality comparing it to 0, but an inequality that compares it to something other than 0.